For 3D printing, we'll want to take a look at this in terms of its orientation. These holes will be a little rounder if we print it as it sits, and these will have a little bit of a droop. We don't really need the text at this point, so let's go ahead and open it up. And if we rotate around, then that would be the face that is going to set onto the build platform. So let's take a look and find the text, and we can suppress that. Again, it doesn't participate. And next I'm going to want to add a few fillets. And what the fillets are going to do is, since it's not a sharp edge, has a little bit better of a blend and doesn't affect the print so much. So let's go with a fillet, and a 1/2 millimeter should be fine. Alright, so that's about 20 thousandths. Alright, so it's not going up and over, so I need to add one more. Alright, so we could put the fillets on the holes as well, but that gives us enough that we'll have that transition, and when we go to take it off of the bed, we'll be able to get a putty knife or a screwdriver wedge razor blade underneath to pop that off if it's stuck really good. Alright, so File, and we're going to look at the Print 3D function. Alright, and the bottom plane of the model was that face that we selected. Alright, so it shows it, but that's not really the orientation that I want it, so let's go 90 degrees. That looks okay. I'm not really expecting it to come into my slicer that way. Our choices are STL and 3MF. 3MF has a little bit more metadata as far as if we're going to do anything with colors, and we'll overwrite my test piece. And if I just do a quick preview, if it needs support, support's not required, it will do a little bit of analysis for us. Okay, so once those are in place, then I can come over to the slicer. This one is Simplify 3D, but I've used Cura and Repertoire, which is slicer with a 3. And we're going to import our base, and it comes in whichever way it wants. So let's go ahead and edit, and we're going to place the surface on the bed. I don't really like the orientation, so change rotation about Z, 180 degrees. So that looks pretty good. I can put in the position, but we have a tool to center and arrange, so that puts it in place. If we go look at the process, these are going to be all of the settings, and right now I have it for a 95 durometer fairly soft filament. So I want to go with one of my recipes. We'll just go PLA left, and no, I always end up making little tweaks as I go along, so I just want the recipes to start. So I have the left extruder highlighted, what the nozzle size is, layer heights. There are a lot of settings in here. The skirt and brim says it will send one path around to get the extrusion started before it starts the print. What do we want for infill? 25%. If I need something a little more dense, I might go up to 50%. Very rarely have I tried to print it 100%. It takes a long time, and it kind of defeats the purpose of the 3D print. And we're not really gaining that much in strength. We're not generating any supports. The build platform, my printer is enclosed, so between 40 and 60 degrees Celsius is usually good, and 200 for the PLA is a pretty good number. Fan speeds, additional codes, scripts to get started, the actual print speed, and then our other and advanced. Alright, so when I have those kind of looked over, then I can prepare to print. It gives me an approximate build time of 2 hours and just about 38 grams of material. And if we go over to the build, and we'll zoom up just a little bit on that, as I drag the slider, it's going to show me how it's going to create those paths and complete the build. Alright, down to, and you can kind of see the skirt around the outside. Alright, so that gives me a point where I can either send through the USB or save toolpaths to the disk. I usually save the toolpaths to the disk because the USB is going to tie up the computer. I don't want to break the communication or have any serious problems with it. So let's get back into SolidWorks, and let's go ahead and rebuild the assembly. So we'll do the same kind of functions, but we'd want to look at this from the standpoint of what can I add as far as the pin and the connections, so that I end up with a simplified print, that I don't have to print all of these as separate parts, but I can still get a lot of the functionality. So in this case, if I print the pins with the crank and the follower, they're going to have to ride in this boss, which may not be fully representative of the function, but will give me a pretty decent look at how it works. Alright, so get the save warning. Let's see, the markup is still popping up, so I think I'm going to go over here and hide the markup. And that'll get rid of that little box. Probably didn't do too much with the markup, but we can edit, orient, show, or hide if it's hide, and then we can export the markups into a list. All right, so let's rotate over. In order to make this so that I can print these pieces as a complete, I'm going to edit in context. And so this is a little bit of an advanced topic, but if I edit the part, then I can come over to the features, and under features we're going to perform a join. Alright, so the parts to join are going to be the pins, and if we hide the existing parts in the assembly, we can go ahead and hit OK, and it said force surface contact. So over here, if we'd printed the other way where I generated that gap, I could either suppress the move face or have it force in that contact. All right, so in the process of changing that, let's see if we can find the pins. The pins are hidden, but they create a conflict, an overdefined condition. So if I go in and edit the coupler, I can see that I have that geometry, but the problem with the pins was those holes disappeared. There's nothing for it to perform the mates with. Right, so really what I need to do is add another configuration, and I hope you're starting to see the benefits of the configuration. Even though we haven't gotten real complicated, we can take this to a higher level of complexity, make it as simple as complex as we like. So in the default, I'm going to come back and suppress, and that will clean up my assembly, hopefully, but also give me the ability to 3D print something that looks like the pins are already assembled into that coupler. And for the 3D print, this is going to be fine. So we'll end up doing the same thing. I'm going to print 3D the bottom plane, and if it'll rotate for me, there we go. And based on the way it came in last time, I'm not really worried about the orientation here. And I do still like the 3MF, so we'll save the file. And basically what it's warning me is that it's tied to the assembly. If I make significant changes to the part file, it could mess up the assembly in other ways. So we're going to hit save. And the preview again if I needed support. I did not put any any fillets on this. So if I was going to, I'd probably just fill it around these two edges and let that go into the build. But since I already went past it, that would be my next iteration of the print. So let's go back. I'm going to remove, and we could try to print these both at the same time using the same material. The issue that I've run into is that if it's going through and then it jumps to the next level, this side's going to cool off quite a bit before the nozzle gets back. There's still going to be some cooling, but if it's in the same part, that heat transfer, and I don't know, it just seems to be better. I'm not in a production environment here, so what I want is one complete part that doesn't have any separation between the layers. And if one of them fails, you know, I'm going to end up with like, say the coupler comes loose and starts dragging into the other one, I end up losing both parts. So let's just go ahead and remove, and we'll import. So if you have a machine that you've used and you've made multiple part prints with, then you know, you can make that decision as you go. So my process should still be pretty much the same, and if I prepare to print, it's going to go through and do the same thing. This one's going to take 32 minutes. The issue with something this long is probably going to be the tendency for it to curl. All right, so when it's you know, if it gets too thin, then when we pull this off, there'll be a little bit of a banana shape to it. So that would be a test, and we could put in some structural holes or an obround to kind of thin out the material so that it doesn't end up with as much stress. All right, so as it builds up, then it starts jumping back and forth, finishes the build. And then we'll get back into to SolidWorks. All right, and we could do the same thing, and notice here the pins are being hidden, and we are still editing the coupler. So let's get out of that, and I want to in printing the other two pieces, then I would join the long pin or the pin to the crank, and then I would join the other pin to the coupler. It's not going to hurt that they're the instances of the same thing. It's just going to pick up that pin and that geometry, and we'd have a something that we could produce a pretty decent print with, and at least check the initial functionality, make some decisions about the load bearing, which faces, the drive units, all of those mechanical things that we talked about in the previous videos.